Saxon Advanced Mathematics, Lesson 50, Trig Equations. If you have taken the time to learn about the unit circle, figured out how to fill it out, and are ready to using it, to start using it, this lesson is a great example of how it can save us so much time and energy. So if you have a unit circle, grab it, like a copy of this. If you don't, look for my video called Unit Circle and figure out how to make one of these for yourself. It'll save you lots of time. Okay, so what we're going to do is we're going to use our unit circle to solve what we call trig equations. Let's just dive in. There are how many? There are 3 examples in this lesson. Okay, solve. And then John says, says, the sine of theta equals 1 over the square root of 2, given that 0 degrees is less than or equal to theta is less than 360. Okay, so what this problem is saying is find us any angles that have a ratio of opposite over hypotenuse, because that's what sine is, of 1 over the square root of 2, but don't keep spinning around and giving us more and more and more. Just give us in the first 360 degrees, and it does want degrees, not radians. In the first spin around the board, give us any that you find that are positive 1 over square root of 2 in that first spin, okay? Well, that's cool because our unit circle just gives 1 spin, right? It goes from 0 to 360. So this has already got the limitation built into it. Fabulous. That's just what we want. And it's got values for sine built right into it. So we go, okay, so we're looking for positive 1 over square root of 2. And we look at this and we quickly see, we don't have any values for sine, the second one in the ordered pair, that says 1 over square root of 2. But I also notice that all of our denominators are rationalized. We don't have any square roots in our denominators. And so that gets me to thinking, maybe the problem here is that John didn't rationalize his denominator. So let's try rationalizing it. I'm going to write it over again just so we can see better. It equals 1 over the square root of 2. Let's rationalize it by just multiplying like so. This now has the square root, and this becomes plane 2. Okay, square root of 2 over 2. That shows up. Again, sine is the second value in the ordered pair. So I'm just looking for square root of 2 over 2. There's one right there. 45 degrees is going to be one of our answers. So theta equals 45 degrees. Now we also know that there are usually 2 positive and 2 negative values, right? When we fill this out, we get that burned into our brains. So I continue looking, okay, over here in the second quadrant, there's another positive one. So 135 degrees looks to be a valid answer. Let's try the third quadrant just to make sure we're not getting confused. And what I see here is, here's a negative, but here's the square root of 2 over 2, but it's a negative. So we won't include that. And I'm noticing that my answers are all falling in the red, the 45-degree triangles. So here's another 45-degree triangle. It's got the right values, but again, it's a negative. So that tells me this is my final answer. Notice how if we understand the unit circle, know how to use it, know how to create it, we did not have to do much work for this problem. We just had to straighten out this thing with rationalizing, which in the future you can do in your head, right, once you get the hang of it. And then we just scan our unit circle and look for the answer. Again, this is only cheating if you don't know how to make one of these for yourself. If you can create it from scratch, then you've already done all the work and it's not cheating at all. Okay, let's do another one. $50.2. This says that we're supposed to solve 2 plus okay, this looks much more complicated and horrifying. Don't panic yet. Stay Stick with me. And again, we have the same limitation put on it. 0 is less than or equal to. Theta is less than 360. Remember that sometimes John will give us this limitation written in radians instead of degrees. There isn't one in this lesson. That's our clue just to use the other information on the unit circle. Doesn't change much. All right, this looks horrifying. This was very cute and simple. But look, we can do some algebra on this to get the trig sign by itself and get all this other business chased away. So here's what we're going to do first. We're going to subtract the 2. And we'll get square root of 3 times the secant of theta equals minus 2. Then we'll divide both sides by square root of 3. That cancels. I'm going to flip. So with the secant of theta equals negative 2 over the square root of 3. Secant of theta equals negative 2 over the square root of 3. Now, I'm starting to panic. I mean, not really, but just work with me here. I'm being dramatic. That's not really my style. I'm not usually theatrical, but now I'm going to. You guys, I'm panicking because we don't have any fractions like this on our unit circle, right? There's nothing that looks like that as I zip around here and think about these. But then I remember, oh, right, these fractions are all cosine and sine, but this is secant. So that means I'm going to have to rearrange this and say, okay, if an angle's secant is this, then what would its cosine or sine be, depending on which one makes more sense for me, right? Okay, so this is cool. Now what I want to do is remember what pair of sides these are. Okay, there's sine, and there's cosine, and there's tangent. Oscar had a hold over Arthur. Now, what are the reciprocal ones? Okay, I know that secant doesn't go with sine because that would be 2 s's. So this must be cosecant. This must be the secant. And then I know this one's cotangent. Okay, so then all of these flip, right? I hope you can see my squishy little notes here. Right? Once I figure out which sides match, then I know, okay, just flip what their partners are, right? These are all my reciprocal functions. So if the secant is this, that means this is the hypotenuse and this is the adjacent, right? So for the same angle, the cosine of that same angle would be square root of 3 over 2 with a minus, right? There's a minus sign there. Okay? If secant is this and secant is h over a, then I can assign those values. Then I can take this same, it would be the same angle, right? Because I'm not changing the values. And I'm just going to rewrite it to capture the cosine function rather than the secant function. They're reciprocal buddies, so all I have to do is flip it. Now I feel really good because I know square root of 3 over 2 is on this chart. I see it here. It's a blue value. This one's positive, so I don't want 60 degrees. This one's positive, so I don't want 120. But down here, see, there's a negative 3 over 2. Oh, wait. My bad. That's the cosine. I want the sine. So I'm looking for the orange functions, right? Because cosine is the first one, right? So that's positive. Here it is as a little negative puppy dog. So I want that one. The angle of 150 degrees gives me a cosine of negative 3 over 2. And that's what I said I wanted. So theta equals, what did I say? 150. And this is why I like to do the colors on these, you guys, because it is helpful. If this was the right answer, then I just look at the oranges in the other circle. Here's another negative. This one's positive. I don't want the positive one. I want this one, 210. These are the two angles that will give me a secant of negative 2 over the square root of 3. These values aren't on my unit circle, but I can rewrite this as its reciprocal, and I'm in business. I have to be careful, though, because I said I wanted cosine. There are some angles where the sine is the value I want. So I just have to be super careful that I'm lining up all of my details. before I grab the answers. Is this the right answer? Yay, it is. Did I say that last time? No, I did not. Let me double check this one. Yep, this is right also. Okay, so what did we do? We did a little bit of algebra to straighten it out. Then we thought about our reciprocal trig functions to translate this into one that was on our unit circle, and then we just looked around and found what we needed. Okay, one more and then we're done. I know, don't you wish this could go on forever? Oh my gosh, it's so fun. Ready? Solve 3, oh, look at me. Whoops, this is, yeah, I'm right. Okay. We have our limitation again. It'll always look like this again, because this is written in degrees. We know that our answer should be in degrees. If this was written in rads, we would simply not take the degrees, but we would take the rads, right? It's all on our chart, so who cares which one it is? All right, just like last time, we better do some algebra, and then we'll have to translate this reciprocal function into either cosine or sine so that it's on our chart. All right, I'm going to subtract. Three cosecant of theta. I'm not letting that function mess me up yet. Divide it by 3. And we get that the cosecant of theta equals, these cancel, so it's minus square root of 2 over 1, right? Cosecant is the opposite of sine. I'm just trying to think of how to use this space. So the sine of theta, that's going to be what we're creating. It's going to be the opposite of that. It's going to be 1 over square root of 2, and it's going to be negative. Okay? I have to exaggerate these because it's easy for me to drop these minus signs and not think about them. So what we're saying is cosecant is reciprocal with sine, so if that's the value of the cosecant we're looking for, we flip it to get the sine, and then we look at our chart. We want minus 1 over square root of 2. Okay, we know that we need to have rationalized denominators. Our chart only uses rationalized, so this will also be the sine of theta equals, and we can just mentally do this, minus square root of 2 over 2. I mentally rationalize that denominator. All right, now, it's sine that I'm looking for. Oh, but this guy, I automatically recognize he is a friend of the 45 degrees, right? He's going to be in the red. So I want sine to be negative. Sine is negative down here at 225. And looking at the reds, 315, there's another negative sine. Sine is the second one. So 315. Again, if this problem had been set up so that the limitations were given in rads rather than degrees, all I would do is, like what was my answer, 315 right here? I would just write 7 pi over 4 instead of 315. It makes rads so much less of a drama when you use the unit circle. All right, let me make sure this is right. 215, 225 and 315, yay, this is right, all right? Great. John does not know about the unit circle. He talked about it very briefly in one lesson way back, but he doesn't do this. He doesn't explain all of this, and I learned this in a college level trig class. So we may be getting ahead of ourselves, but this is just such an important and useful tool. And being able to develop all of those numbers, if you can do that, you are freaking smart, and that's all I have to say. Okay, guess what? That's all there is to lesson 50. That's a lot. If you can wrap your head around those problems, man alive, you are doing great, especially the first week back. Again, I think I said this last time, but this first week, Your brain's gonna wobble a little bit. Mine is too. Okay, that's all. Lesson 50 is done. Goodbye.